So the next step is to actually create the first field, which is area, because we need a square miles to actually create population density field and so on and so forth. So I'm just going to create an area field and calculate square miles, use square miles. I'm just going to calculate that, keep it aside. I'm going to add one more field called population. I'm going to add something before that. I'm going to add a field called aggregate income. So because I'm trying to do income density map, so I'm just going to create a aggregate income field where I'm going to calculate that based on a formula, simple formula, which is total population multiplied by per capita income. So I get my aggregate income. The next step is to actually add a field called, the next field I'm going to create is called population density. I'm going to create a float field. I'm going to create one more field called population, actually income density. I'm going to calculate these fields fairly easily. It's going to be aggregate in population density is going to be total population divided by area, and income density is going to be aggregate income divided by the area. Okay, I got the two fields I need, and I need one more field called target population, which is nothing but the total of my age groups population, which would give me an aggregate of ages 25 to 40. So I'm just gonna sum them up. I'm gonna add one more field called target population density. I'm gonna calculate that field based on target population divided by area. So I got all the fields for my analysis. What I'm going to do now is actually we need to do one more thing, couple more fields, actually field X and field Y. And calculate the geometry for those. As you know, calculate X coordinate and calculate Y coordinate. So that's it. Now what I'm going to do is open the attribute table, export that table into as a census data table, add it to the map, and now I'm going to display XY events, and I'm going to import the census track coordinate system so that they line up pretty easily. So there it is. I'm going to turn those off, and I'm going to bring in my county boundary which I downloaded. I'm not gonna show you how to download and add a county boundary, but you should be able to figure that out fairly easily. So that's the county boundary. I'm gonna make that hollow and add some weight to it so that we can see it. And now I'm going to set some raster analysis environments. So I'm going to set my raster analysis to specify it as actually just leave it like that. The mask is going to be St. Louis County, and I'm going to click on OK, and let's zoom to our layer, save this map under final projects, where is C drive, ESRI, press GST to final project. I'm going to save this as base map, actually final project yash. So once that's done, the next step is to actually create the model that we need to actually run the analysis. So I'm going to click on catalog, right click and click on new toolbox. I'm going to create a toolbox called site suitability, and I'm going to create a new model within that, which would be called site suitability again. So I'm going to rename that as site suitability analysis. Okay, I'm gonna save that, close that, and open it again, obviously, edit. Anyways, so I'm going to use IDW, which is interpolation methodology, to actually create all my rasters. So let's see how that works. I'm going to type in IDW, and then I'm going to bring in my census tracks. Then I'm going to drag and drop as input points, and I'm going to use the Z value as population density. Output cell size is 465 something. I'm gonna set the output size as 50, and I'm going to set the power to 4 because I just need like smoother looking rasters. And then I'm going to save this under my USRI press final project database, call it pop density. Okay, I'm going to click on apply, click on OK. Let's see, let's add that to the map and click on run. So once that's calculated, you should see a raster like that, which actually gives you population density. I'm going to go to properties. I'm going to classify that based on natural breaks. I'm going to use maybe, I'm not going to spend too much time on this, so I'm going to say higher I'm going to pick hotter colors for higher densities. So there it is, that's our population density raster, which is excellent. I'm going to save that, and I'm going to go back to my model and drag and drop spatial analyst IDW a couple more times. So I'm just going to use this same for the second one. I'm going to use income density, and again output cell size is going to be 50 and power is going to be 4. I'm going to save it as income density. Okay, I'm going to apply, okay, add that to the map. Don't run it yet, we're going to run everything together. So just going to select the next one's going to be target population density. I'm going to select, I'm going to change some of these values, as you know. I'm going to call it target population density. I'm going to click on apply, click on OK, add that to the map, then auto layout obviously, and then zoom out a little bit. And now I'm going to run this analysis. You can do it individually, or you can click run the entire model, but I'm just going to run them individually. So let's see what happens when you run all of those. I'm gonna run the target population as well. So looks like my models have been run, so I'm just gonna take a look at each one of these individually. I'm gonna use natural breaks for all my classifications. I'm going to classify them using, just select different colors for that. Income density, classify, natural breaks. Okay, I'm just gonna pick different colors for this. Just gonna talk. So that's income density, that's target population, and that's population density. So we've got 3 rasters. If you want more, you can add more, like you can add population growth, you can add a couple more. I'm not gonna go into the whole site analysis methodology, but this is a very simple way of how to perform a site suitability analysis. So we got this model, we run this analysis, but what's the next step? So we sort of need to combine all this data together to come up with a final conclusion. So in order for me to do that, I need to actually reclassify some of this, 3 of these rasters to actually start do a raster math eventually. So I'm just going to click on reclassify, drag and drop reclassify, like again 3 times obviously, and now I'm going to use these rasters to as reclassify inputs. It's pretty simple. It's your own methodology obviously. So this is reclassify value field. I'm gonna classify, you can classify that based on natural breaks, and then you can add values like 1 to 10. Looks like that's a decent classification. You can go on and on about like the theory behind it, the data classification methodologies and whatnot, but this is not that kind of a video. This video will show you the process, and you can figure out what you want, what values you want to classify, and all that little later. So I'm going to call this income reclass. I'm going to click OK. I'm going to open this. I'm going to classify that based on natural breaks. I'm gonna call this income, actually target population reclass, and then I'm going to do the same thing here. We got the wrong tool here. We don't need that geoprocessing tool. I'm gonna go back to search, drag and drop reclassify tool, and now I'm going to input rasters, the population density. Now open that and reclassify that data based on, again, this is pretty straightforward. This is a very simple methodology that I'm using to explain the process. So don't ever think that this is the way to do site suitability analysis. This is just a methodology. And then I'm going to call it pop density reclass. Okay. I'm going to apply. Okay. And now I'm going to add these maps to the display. So the basic idea is to, as you can see, the higher the values become, you get a higher value. So the new value, all the values between these classifications will become a value of 10, so on and so forth, which would make your life so much easier, because when you actually do a raster math and combine all this, you are looking for areas which have a value of 30 or more. so that you know that those are the hottest areas, and hence you probably have a chance of actually starting something there, like a retail store or a grocery store. It could be anything. And again, the variables that you use are entirely up to you, and it's an it's open for interpretation essentially. So I'm gonna run all this. I'm gonna run I'm just gonna run all these models, and once they're done, you get this is the income reclassified raster. It's gonna come up with some crazy colors, but you can use a monochromatic ramp to actually make some sense out of it. Or actually, this is a intermediate raster, which means we are not gonna show this to anybody. This is like a we're not gonna use this in a final map, so don't worry about actually making it look nicer. But the next step is to actually do the raster math and come up with a final analysis. So I'm gonna run all of this. So there you go, it's all done. I'm gonna save this model. I'm gonna minimize this, and now, as you can see, if you actually put them in a monochromatic ramp, you can actually see that it looks very similar to what you already know. So I'm gonna use weighted overlay to actually find out my results. Just gonna use all these three reclassified rasters to actually my weighted overlay geoprocessing tool. And now I'm gonna say that looks like we need, so this is the percentage of influence. If you think that income is more important, I'm gonna give a weightage of 50 to income, and target population is gonna be 25, and then population density is going to be 25 as well. So again, this is totally my own analysis. This is again a very simple analysis. This is not the scientific method of actually doing it. But once that's done, I'm going to save this raster as final raster map. And then I'm going to apply this. I'm going to run this analysis and see what happens. So let's add that to the map, and looks like we got our final analysis. Just gonna use a ramp that suits my needs. I'm just gonna use a ramp like that. Click on OK. I'm gonna turn the rest of the layers off. So looks like the areas which have a value of 9 or above, or value of maybe 8 or above or something like that is what we are looking for. So you can actually perform one more analysis on top of this. So the next step is to actually perform an analysis called contour list. So contour list. So I'm just going to add that to the model. I'm going to input that as a raster, and then I'm going to save that as a feature class called target areas. The contour value is gonna be 8 and above, so I'm gonna say 7.5 and above, or actually let's go with 8. So you click on apply, click on OK. So let's run that analysis. So we made a mistake of validating the entire model, so I'm just gonna use drag and drop my final raster raster and use that for my final step of contour and contour list. So anyways, you can use that to sort of run your final analysis and then add that to the map. So looks like those are the areas which have a value of 8 or more. So those are your target areas. So I'm just gonna increase the line weight to maybe 4 or something like that. So as you can see, those are the target areas. Now I'm gonna go into those areas and start looking for what works and what doesn't, or maybe actually start adding existing competition and look at what needs to be done. Okay, look at market feasibility that way. So off to the next step.